welcome to a very important and interesting class on chemistry, which is the determining the positions of elements in the periodic table from their electron configurations. So this is very interesting and very important to understand where the elements belongs to in which positions that can be determined from their electron configurations. And this is very important, and this is also very interesting if you understand the electron configuration first. So to understand this topic, I hope that you already know the electron configurations. You know about the orbit, you know about SPDF orbital, and you of course know about the electron configurations, because in my previous class that I uploaded about electron configurations, I say that the electron configurations is one of the important and basic of chemistry to know that how to write the electron configurations of an elements. So if you know the electron configurations, from that we can understand and we can determine that which group and periods an elements belongs to. So let's start to understand. Before going to explain it, you see that this is the modern periodic table where 118 elements are there, and then you know the number of periods. We have 7 periods in periodic table and we have 18 groups in periodic table. And of course you already watched my videos that I have uploaded about the characteristics of periodic table. On that video I say the number of elements in each groups and each periods, and most often you know that the group numbers and period numbers, like there are 7 period numbers and 18 group numbers, and now we need to find out how to determine the positions or the group number and the period numbers of an elements. You see, first that we need to know that we need to find out this group and this period from the electron configurations. If you see at first that there are 4 orbitals, S, P, D and F. So understanding the period is easier, but determining the group is something technical, because periods are determined from the outermost shell number of an electrons, or like of an elements. Like if I go for like that potassium, suppose I started from like sodium, okay, so started from sodium, the electron configurations of sodium, you know it, the atomic number of sodium is 11. So if I go simply, then it would be like 1s2, 2s2, 2p6 and 3s1. You know it well. And now you see that there are 3 shell of these electron configurations. So the number of outermost shell is 3. So the outermost shell will define the number of periods where these elements belongs to. So as it is 3, so it would be in the 3rd period. So sodium belongs to 3rd period. And now you see that we need to determine the group number. So here in S orbital there are only 1 electron. And simply we need to know there are some systems. So the systems to identify, systems to determine group number is, number 1 is, if you see in S orbital, the number of S orbital would be 1 or 2, right? And this is actually the group number. So the number of electrons belongs to in S orbital is the directly group number of that element. And coming with the elaborations, number 2 is, if you see that there are S and P orbital, suppose in S orbital there is something and in P orbital there is something, and till which level it can go. So in S orbital it can go for 1 to 2, and in P orbital it can go for 1 to 6. So if X is 1 to 2 and Y is 1 to 6, then the group number would be X plus Y plus 10. This is very important. when you see that the electron configuration ends at p orbital and also there are s orbital first in one shell, then you have to use the number of electron summation plus adding with 10. This is very important. And also number 3, when you see that s and d orbital together, in case of s orbital it can be 1 to 2 and in case of d orbital it can be 1 to 10, then you just add if it is m and if it is n, only the summation of m and n would be the group number. So you have to remember these 3 systems. Okay, this is very, very important. So only s orbital, the number of s orbital is the group number. S and p, if s orbital and p orbital stays together, then we have to add the number of electron of s and p. P orbital would be definitely after when s is 2 and then p. We have to add plus 10. In case of s and d orbital, only we will use the number of electrons in s and d orbital, and that additional number is the group number. So I think you understand the primary discussions and primary technique to identify the group number and period number. Determining the period number are very easy. That you see that number of outermost shell is 3, so you know that this is the period number of 3, but need to know that the group number. So right now I'm giving you some examples. Suppose I'm thinking about beryllium. Okay, so beryllium is 4. So I know that this should be 1s2, 2s2. Here only s orbital. So the outermost shell is 2. So beryllium belongs to the period number 2 and the group number 2. You see, period number 2 and group number 2. If I go for fluorine, so which is 9, okay, now you see that in 9 this should be 1s2, 2s2, 2p6, no, it will be 2p5. Now you see that the electron configuration of fluorine goes to s and p orbital, and you know there are only 2 outermost shell, so this is the second period. I mean, fluorine belongs to period number 2, but now the group number, you see that s and p, why we need to have s and p, then we need to add x and y plus 10. So we have 2 and 5 plus 10, then the group number would be 2 plus 5 plus 10 is 17. So that is why fluorine belongs to period number 2 and group number 17. You see, period number 2 and group number 17 is fluorine. So now if we go a little bit bigger number, like if I say for calcium, or like even if you go for iron, iron is 26. It's 26. Now we can see that 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s, and you know that it will go first 4s2 and then 2 to 4, 6, 10, 12, 16, 18, and this will be 8. I think it's right, yes? No, it will be 6, I think. Okay, now if it is the electron configurations of iron, now you think that how many shells are there? Irons configure like 4 shells, like 1, 2, 3 and 4. So the number of outermost shell is 4. So iron belongs to period number 4. Period number 4, and then you know that s orbital comes with d orbital together. So if we have only s and d, we need to add only the number of electrons. So we have 6 and 2 together. So if we add it, we will get 8. So hence iron belongs to number 8 group. So how to figure out the group and how to figure out the periods, I hope you understand these systems. Number 1, that if only it ends with the s orbital, we just think that the number of electrons 1 or 2 would be the group number. That is basically happens in these 1 and 2 group. If you do the electron configurations of these groups, all elements, like there are 7 and 6, 13 elements up there. If you do the configurations, all these 13 elements, you will have always like 1s2. I mean, they will end up with 1s1, 2s1, 2s2, 3s1, 3s2, 4s1, 4s2, 5s1, 5s2, 6s1, 6s2, even 7s1, 7s2. You will have these configurations at last. So, if you go the electron configurations of francium, then you will have at last 7s1. So it means that the period number of francium is 7 and the group number of francium is group 1. And if you go deeper here also, like in copper, I think, copper. So if you go copper 29, it will be like 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s1, 3d10. This is the electron configuration of copper, you know already. So you have seen there is 4th shell, the electron comes at number 1. So the period number of copper is 4. And as there is 3d and 4s, as we have only d and s, we just add the electron of d and s, that is 11. So copper stated determines the position of copper, it's number 11, group number 11, and the periods number 4. So we have copper in 4th period and in 11 groups. So if you see again in scandium, like scandium, so scandium is 21. Scandium is 21, so you can say 1s1, 1s2, 2s2, 2p6, 3s2, 3p6, 4, 3d, 1, 4s2 is the electron configuration of scandium. Now you see 4 is the 4th period. It stated like D, you see only D1 and 4s2. So if you add D and S, you just add the M and N, that is 1 and 2, which is equal to 3. So scandium belongs to the 4th period and 3rd group. So now, if you do the electron configuration of any elements, you just follow this system. If you have S and D together, add it normally. If you have S and P orbitals, then you add electron numbers plus 10. But if you have only S orbital, just that numbers is the group number. So this is a very short and simplified lectures on the determining the positions of elements in periodic tables based on their electron configurations, and I hope you understand that what I'm explaining, and of course determining these positions of next level depending on your practice. And I'm requesting you all to do some practice in these rest of the elements out there that I have not written here, but you know that there are some electrons and there are some elements out there. So if you do it freehand, practice at home, that's strontium, tellurium, iodine, xenons, and of course you know that argon, krypton, xenon, they will be like the 18th shelf. Every inert gas, they will have S and P like this. All these things. So in case of neon, it would be 2s2, 2p6. In case of argon, 3s2, 3p6. In case of krypton, it would be 4s2, 4p6. In case of xenon, it would be like 5s2, 5p6. In case of radon, it would be 6s2, 6p6. It means in case of radon, if it is 6s2, 6p6, it means that the outermost shell is 6. So radon belongs to the radon. So yes, radon belongs to 6th number period, and as it is S and P, so we have to add 10, so it is 18 number group, which is inert gas. Okay, so I hope you understand that what I am trying to explain here, determining the positions of elements in periodic table based on their electron configurations. I am requesting you to do it freehand at your home and try to write all the electron configurations of all elements and then try to figure out the positions of that elements in the periodic table. And I hope you understand, and please keep watching these videos and to let me know your feedback. Do you understand really this? And of course do some comments in these videos and let me know your feedback. Take care. I'm coming with new videos with periodic tables later on. Take care. Bye.